Bismillah ar-Rahman ar-Rahim. Gentlemen, it is in a continuation of the previous lecture, lecture number 9, and this is your lecture number 10. In the previous lecture, we have discussed the protection of a transformer. So this is in continuation with that. We have discussed all the transformer protection, that is by fuses, by overcurrent relays, and by differential protection. Although we didn't cover the protection of transformer by fuses, because that of course a long chapter, so that is not included in this particular course that we normally teach to postgraduate students. But in general, we can say that transformer has three category: low power, middle power, and of course high power. The low power is of course protected by fuses. The middle range is protected by overcurrent relays, and of course the high range it is protected by differential relay. In the high range protection, differential protection is the main protection. But overcurrent is also used as a backup protection. I'll give you a map or circuit which combine all these protection in one diagram at the end of this Buchholz relay. Okay, now Buchholz relay was first developed by a person Max Buchholz in 1921. Buchholz relay have been applied to large power transformers. Buchholz relay is a gas actuated relay installed in the oil immersed transformer for protection against all such kind of fault. It is used to give an alarm in case of slow developing fault in the transformer and disconnect the transformer from the supply in the event of severe internal fault. Now you see here, gentlemen, this figure shows this is the general, that is the main tank of the transformer where the windings are being there. So if you see long, you might have seen this type of figure, a pipe emanating from this tank, and it is going this way, and there is a tank. This tank is basically called conservator tank or conservator. This conservator contains basically a material silica gel that is actually absorb the moisture if any moisture here there in the transformer. Okay. Now in between we have a Buchholz relay. So any thing going from the tank up to the conservator passes through this Buchholz relay. So this is of course the placement of the Buchholz relay in the transformer installation. Main tank, pipe running. This angle is around about 9 to 10 degree. The slope of this is 9 10 degree, and in between this pipe we have a Buchholz relay. Buchholz relay, the here and it's going out, and then of course we have the conservator. Basic construction. This device has two elements. The upper element, this will be, I think, with the help of that diagram. Anyhow, so I'm writing this, then I will explain with the help of that particular diagram. The device has two elements. The upper element consists of a mercury type switch attached to a float. The lower element contains a mercury switch mounted on a hinge type flap located on the direct path and the direct path of the flow of oil from the transformer to the conservator, which is in contact with other flow. The upper element closes an alarm circuit during slow developing fault, whereas the lower element is arranged to trip the breaker in case of severe internal fault. Okay, gentlemen, now see this figure. This is important to understand. This was that input from transformer and this is of course the pipe entering here, and this is of course filled with the transformer oil, as normal transformer oil is used in this particular tank. So it is not 100% filled. Some portion is of course uh, not having the oil, it is just air or any other gas if we have. Now, the transformer oil, when heat produces, if we have incipient fault means slow, uh, initially slow fault or low fault. So it produces, of course, heating effect. Due to the heating effect, the transformer oil, which is in the main tank, decomposes into a constituent element. The elements, of course, two elements are common because organic compound, it is carbon and hydrogen. So about 70% of the its part is of course hydrogen gas. So hydrogen gas enter this tank, and since hydrogen gas is lighter, it go up, and with it go it is entrapped in the upper portion of this, which doesn't contain of course oil. And when a certain amount of gas is accumulated, it apply pressure on this float, and at this float, this is because this is your hinged point, this is your hinged point, and that float just go down, and a mercury switch is attached to this float. There, this is mercury switch. This is of course this black type of thing is equally mercury. When it is in this position, it is not short circuiting these two terminal, but when this float is tilted, this mercury short circuited, mercury being a conductor, short circuited these two terminal, and these are the terminal of the alarm circuit, and an alarm is sounded in the control room, and then of course the engineer on duty is go and disconnect of course the transformer, manually disconnect the transformer from the supply and do certain repair work. These are it which are required. So this arrangement is only to detect the incipient fault, which is not detected by any other type of protection, right? Okay. Now the second one, if a serious fault occur, student, when a serious fault occur, lot of heat is produced, and this lot of produce actually decomposes the oil, and a high pressure hydrogen is produced, which while pushing the oil into this inlet, and while pushing the oil into this inlet is just tilt this flap. This is a flap, and this is hinge here. This is hinge here. It is flap, and it is moved, and also a mercury switch is attached to it, and whenever it moves this way, and of course the mercury switch contacts are close by the mercury, and it directly connect to the trip circuit, and it trip the circuit automatically. There is no alarm, but it trip the circuit. Gentlemen, once again, just briefly, you have seen the placement of this buccal relay in that particular arrangement. That is the pipe emanating from the tank to the conservator. It is of course in that particular arrangement is being. So whenever we have incipient fault, it produces gases, and that gas is entering into this tank. The major portion of that gas is of course hydrogen gas, which is lighter, and it go up and entrap in the space above the oil, and of course then it applied when a certain amount of gas is accumulated, it applied pressure on this float, and the mercury switch is the circuit is completed through this mercury switch. This circuit is of course alarm circuit, which is completed through this mercury switch, and of course as I explained, alarm is sounded, and then of course the engineer at duty go and disconnect the transformer from the supply and do the certain repair work. Okay, now for serious fault, a lot of gas is produced, which of course move along with some oil with pressure into this, of course, buckles relay, and it, of course, tilt this flap to this side, and of course, this is also hinge here, and of course, another mercury switch is attached to it, and of course, this mercury switch again short circuit this terminal, and these are the terminal of the trip circuit directly, and directly the circuit breaker is operated, and the transformer is, of course, disconnected from the rest of the system. Okay. uh, Types of fault: incipient fault or slow development fault, earth fault, winding short circuit, a puncture of insulation, short circuit between phases. These are those fault, uh, description of those fault which are not normally detected by the other protection provided. That is overcurrent protection, that is the differential protection or overcurrent protection. So I mean from these fault, it is only attributed to this particular Buchholz relay. Now, advantages of this type of relay: it is the simplest form of transformer protection. It detects the slow developing fault at a earlier stage, much earlier stage than other form of protection. So, of course, if the fault in the initial state is not being detected and has not been removed, then of course it may convert into a serious fault later on. So this is the main purpose, that it just detect the fault initially, or incipient faults are being detected with this type of arrangement. Now, disadvantages of this: there are certain disadvantages. This type of Buchholz relay is basically used with oil immersed transformer equipped with conservator. If the transformer is not oil immersed, this relay cannot work, because it is basically used the pressure produced by disintegration of the transformer oil into hydrogen gas. So this is one drawback or disadvantage of that. The device can detect only fault below oil level, the transformer, leveling the transformer, because above I have shown you the space, which is, of course, there is no oil. So if the fault occur here, it will not work. This relay will not work. So for that we have to devise or use other type of protection. Uh, Therefore, separate protection is needed for connecting the cable. Separate protection has been provided. Okay. Now, gentlemen, the summary of this chapter. That is, the summary of the transformer protection is given in this particular diagram. Very important. Okay. Now, starting from the top, that is, the main protection for large rating transformer is differential protection. So this differential protection is the main protection, right? Then, of course, we have overcurrent protection. This overcurrent protection is basically uh, you may say the backup protection. If suppose the differential protection fails, then of course the backup protection will of course clear that particular part. So always we have seen in this protection scenario that always we have the main protection and then we have a backup protection. Always backup is provided in these type of scenarios. Then we have another relay shown here, which detect only ground faults, restricted earth faults, right? So differential relay is the main relay, overcurrent is the backup relay, and then of course we have these auxiliary relays, either Buchholz relay or thermal overload relay. So both function is the same, that is the Buchholz relay function and thermal relay function. I have told you already, or if I have not told you, Buchholz relay are basically used in those countries who follows the British system. like Pakistan, UK by itself, and of course Canada and all these. Mostly in America, we have thermal overload relay, which actually works on the principle of a bimetal strip when it is heated. And then, of course, the expansion of two metal having different property is expansion is different, and on account of that particular a relay is being designed, which work of this thermal effect of the materials, right? So this, of course, can explore so many things. This one diagram is, of course, enough for you to understand the whole protection system of the transformer. Okay, gentlemen. Continuing with the same lecture, the second type of equipment which we have to provide protection is generator protection. Now, gentlemen, you know the generator is the most important and costly component. Therefore, it is a very complex protection comprising of the protection of prime mover, excitation system, voltage regulator, cooling system, etc. Gentlemen, it is a very serious type of matter that, let's say, for example, in this power crisis, if let's say, for example, a generator in the Bavda and the Tarbela powerhouse is damaged, so you cannot imagine the thrust of that or the agony of that particular generators which have failed in this particular season, and of course the power shortage. So a modern generator set is generally provided with the following protective scheme. Number one is, of course, stator protection. For stator protection, which is the main component of the generator, stator is the main component of the generator. You just note this point. Percentage differential protection, protection against stator interturret fault, and number three, stator overheating protection. The second important uh, component of the generator is, of course, rotor. Field ground fault protection and loss of excitation, and protection against rotor overheating. So these three type of protection for the rotor. Then, of course, we have some miscellaneous type of protections: over voltage protection, over speed protection, protection against motoring, protection against vibration, bearing overheating protection, and protection against voltage regulator failure. Gentlemen, you go through all these my narration also will see, and this note point, minor point or major point, I'll explain all these points with you in the next interaction class, inshallah. Okay, first of all, and our main focus here in this particular generator protection will be on stator protection, because if we have to discuss the protection of the whole generator, then of course it just become a book by itself. So therefore we will just confine ourselves to the stator protection, which is the main component of the generator. Percentage differential protection, basically percentage differential protection is used for it. Figure shows the schematic diagram of the percentage differential protection. Figure will come soon. It is used for the protection of generators above 1 megawatt. It provides protection against winding fault, that is phase to phase and phase to ground. The percentage differential protection, which is also called bias differential protection or longitudinal differential protection, does not respond to external fault. Okay, now see, this figure is of very important for us. These three winding is, of course, three phase generator, shows three phase, three winding, one winding per phase, right? And these are connected in star fashion. This is your star point which is earthed. And this is the circuit breaker which connect this generator to the outgoing circuit to the outgoing circuit, because if this circuit breaker is open, it will not provide to the outgoing circuit or to the system. So this connect the system with this particular generator. So we have installed CT on each phase. This is CT incoming, and this is, let's say, outgoing, CT and CT and CT and CT. And a differential scheme has been, you see, a differential scheme has been shown here in this particular diagram. Now, gentlemen, let's say we have earth fault here. We have earth fault here. This is your earth fault. And this is not internal generator fault. It is external to the generator. So this protection which is provided for the generator will not respond to this fault. Right? See here. Let's say this is the direction of current IA. So if there is no fault or external fault, the direction of current in this winding, which is entering and going away, will be the same, right? So these CT carry the current in the same direction. Therefore, the output direction of the current in the CT is the same. This is of course this one, and this is of course that one. Similarly in all phases. Similarly in all phases, right? And then they are combined for differential scheme. So under this condition, since both these current are in the same direction going out of this CT and both have the same magnitude, maybe the fault current, but having the same magnitude, therefore the current in the operating coils is zero, because both these current are of equal magnitude and opposite direction. So the net current in the operating coil, this is your operating coil, you know about it very well. And similarly in all other three coils, we have the similar condition. So the relay will, this differential protection will not respond. Right? Gentlemen, go through this, see it carefully, think over it personally, right? And then if you have any question, I'll explain that question in the interaction class. Okay. Now, this is of course the scenario where we have internal fault. What is internal fault? Internal fault within the winding of each phase or any. So here you see that we have this winding uh, shown here. We have shown here this winding, and this is your fault point, right? It is earth fault at one phase. Okay. Now, gentlemen, this is the direction of current, and since we have earth fault, this current will go. This current will go into the ground, and of course, the current in that particular phase will reverse. You know already you have performed plenty of fault analysis, and whenever ground fault occur, the current reverses the direction, right? But in all other phases, the direction is the same. You see, this direction is reverses, but in all current direction is the same. Therefore, for this phase only, where the fault occur, the operating coil is this coil, and this operating coil, you can see that both the direction, that is the both the CT direction and the operating coil has the same direction. So therefore, this is of course enough to operate this differential relay, but this is not in occur in other phases. The other phases are healthy phases, right? There's only one phase is shown, just an example to you. So therefore, you must see it, and I'll explain more about it when we go into the interactive class. Okay. Okay, now, gentlemen, this arrangement is for the protection against ground fault. We will discuss this point in the coming lecture, that this differential protection, which is basically provided for the line to line fault, also provide protection against line to ground fault, phase to ground fault, but not 100%. It provide 100% protection. It provide 100% protection for face to face fault, but it provide only 80 to 85% for the ground fault, right? Fall-Limsky protection is adapted to provide protection against ground fault. Therefore, a separate sensitive relay is being designed to clear all ground faults. This scheme of protection does not provide protection against face-to-face fault because it is between line and of course the neutral wire, and you see the unbalanced current flow only into the neutral wire. For line to line current, there is no current flowing in this. Okay. Now, a very important point here is to see in case of stator fault, the tripping of circuit breaker to isolate the faulty generator is not sufficient to prevent further damage, as the generator will still continue to supply the power to the fault under until its field excitation is suppressed. Until its field excitation is stopped. Therefore, the percentage differential relay initiate an auxiliary relay, which in turn trip the main circuit breaker, trip the field circuit breaker, shut down the prime mover, turn on carbon dioxide gas if provided, and operate an alarm. Gentlemen, the function of this carbon dioxide gas CO2, is basically if there is any danger of any fire, so it just used to extinguish that particular fire. And when an alarm is operated, because if suppose a fault occur on the stator of the generator, it is normally declared as emergency in the powerhouse, right? So therefore, an alarm is normally, of course, operated, and carbon dioxide gas function is, of course, to extinguish any, of course, fire if it is, of course, started, right? This point is explained here, which I explained previously, but it has been written here. Percentage differential protection provide complete protection, 100% protection of the winding for face-to-face fault, but it does not provide 100% protection to ground fault. It provides only 80 to 85% protection to ground fault, depending upon the effective ground impedance. Therefore, the differential protection is supplemented by a sensitive earth fault relay, which you have seen in the previous. The figure for that arrangement is that. So this is sensitive at just act when even a minor ground fault occur. So just it is in another type of to strengthen the whole protection system of the generator. It is being provided, right? So this, of course, complete this one. Of course, we have, this chapter is not been completed, but of course, the narration that for the next interaction class is completed. Thank you very much.